This is going to be a video about the videos in this course, what kind of videos there are, and what the modules of the course are, and so on. So if we have a little look here, so it's just an Excel sheet overview. This module 1 is Introduction to TI Portal, Overview, New Project, Configure Devices, Function Block, Instances, and instance of a function block and function, the task background, because we have a project template here. Multi-instances, tests using PLC simulator, everything okay with program error, a panel introduction with communication, a panel introduction with screen object, and a panel test. And then backup and archiving of your project. So this is introduction. You should go through this. And the TI portal overview and stuff, you should get to know the program, check what the menus are, what you're doing, and so on and so on. Then we have two compendiums here. We have one called Safety, Automation, and Supervision. This is what you do in process control, not as much in factory automation or process automation or factory automation, but there is a little in factory automation too. And here is safety, automation, a little bit continuous control and controller tuning, other controllers, sequence, batch, machine, and robot control, which are really small. It's just an introduction to. And then we have for supervision and control, and about what are we doing, messages and so on with the system. And then it's a little about human-machine interface, a little on how to design and what to do and what not to do. But of course, this is just scratching the surface. And then we have this how to program of SIMATIC S7-1500 and how to program it. So here's about programming logic control, 1500, IO connections, location, Profinet, program model, and so on. Program general and guidelines, and there's this template project that we're using. And there are some examples in here too, and a short one on this HMI panel. But we are not doing HMI panel programming, not a lot of it. There are several reasons for that. One reason is that the time, of course, it could be something for a separate course, but you can do so much in there. Basically, in this basic video here, but we just put a circle on the screen and had it flash, and you can do more of that. And moreover, is that this TI portal for HMI programming. There's no rapid application development, no mass instructions you can do, or not much for the graphics and stuff like that. And you can have templates for objects or things that you know in the screen, and it's a pain to make. And in these standard panels, what they had, the comfort panels with the special operating systems, you can do much. And the new one, which is called WinCC Uniform, what it's called, I can't remember, but the new one is web technology. Yeah, and here you are going to do a lot of JavaScripting, And JavaScript in itself is an awful programming language. But that's the front-end programming language for some systems like this, so that's what you have to do. The good part is that there's a lot of help concerning JavaScript programming out there, a lot. And you are going to need that. You can do something without scripting, but it's time-consuming and tedious, and you have to make pretty much everything from scratch. There's a good thing with this unified WinCC Unified is what it's called, is that you have screen management and some built-in. The messaging system with alarms and stuff, it's just awful. So that's a part of it. So if you want to make some HMI system or SCADA or something, get hold of a SCADA system, an external one, and communicate with the PLC using OPC UA, for instance. So get a third-party product that's meant to be used as a HMI system. So what can we use this WinCC stuff? Unified or this comfort stuff is just going to disappear. What can you use it for? local operating control, where you have a couple of buttons and you display something, numbers or something like that, but it's meant to be a complete HMI system. But you can't afford that. You can't afford to use this. You're going to get gray hairs when you're going to use it. And for the unified, you have to program everything. There's JavaScripting everywhere. But of course, there's going to be a community for this in a while, and maybe it's going to improve. So you should follow it. But for now, maybe just for local operation panels. And don't try to make a serious HMI with the stuff I've tried to do this, and it's costly, to say the least. So okay, but here are some lectures too for mechanical barriers that we talk about in the safety stuff. Fail-safe PLC, object-oriented programming is a little, fuzzy logic control, model predictive control. It's a little about SCADA and HMI system, what to do and what not to do. PLC evolution. So where are we now? Where did we start? The communication for PLCs. It's a little about that. There is something about a frequency converter or a drive, which is an integral part of TI Portal 2, but we are not looking into that at all, because that's just, it's not bad, because it's, you insert it and there's a lot of parameters you have to set up. A drive can do everything and nothing. So there's a little, but this is about the principle behind the frequency converter, let's say the high voltage or the power electronics, and how it works internally with ramping and so on. So just an introduction so you know what a frequency converter is. And then there's something new about communication. This is OPC UA general, but it's something called FLC initiative or field exchange. So how to communicate, have a standard communicate between automation devices, let's say PLCs, and from PLCs to devices by instruments. That has to do with these field buses. You have a lot of proprietary field buses with functionality or no functionality, no matter what. And there's a little about PLC I/O too. Yeah. So these are videos that you can look for information. So they're kind of lectures. Now here too, we have introductory exercises in this. They are built in this project template we are using. And here are some basic stuff, and there are some easy, some harder, and some easy again, and so on. And you can pick some. There are 10 of these. And then 2 in this sample project. We don't have models in a lab. They change. And usually lab models that you buy for courses and things like that, they are awfully expensive and lack functionality. As an example, we do some intersection control. And you can buy, let's say, a lab model for this. And last time I checked, this one was 40,000 Norwegian kroners, which would amount to something $400. No, $4,000. Dollar is about 10 kroners to a dollar. You don't buy things like that. You make a program in the PLC and you work with that program. You make a screen, we have flashing lights and everything. And that's also for tank level control. So you make models in your PLC, or you could make models in a simulation program, whatever, and connect. But we do internal connections. And also because the only thing you need is your PC with TI Portal installed and a PLC simulator and a simulator for HMI. This course uses the Comfort or the old HMI and not the unified. It could do that, but it's so expensive and time consuming to make these models and this stuff and adjust it that you can't afford it. But then again too, you can make virtually any kind of model in here. This tank that's in here is a second order model and integrated with noise and so on. So you can make simulators so you can make more complex programs and so on. This trans-sorting control too is internal. So you save a lot of money here on lab equipment. So what you are losing is the screwdriver stuff. Connect and disconnect, things like that. But now, this is about PLC programming. This is not a course for electricians. do connection. Now it's pretty easy to work with a PLC and do, let's say, connect and disconnect and look for errors in a plant like that. But that's not this course. So this laboratory models or whatever we do, we don't have those. So what it is, signal filtering. So we have something generating noise, that's sinusoid. Bistable control, that's a state machine, controlling a valve or a motor or something, tank level, continuous control. Here there's factory automation, do some basic sorting. And then we have the intersection control and intersection. Of course, you can do that with a standard PLC because it's not improved. And the last one here is a Morse encoder. That's just for programming fun. And again, a state machine. This is continuous. This is continuous. This is a state machine. This is continuous. State machine, state machine, state machine. And there's a lot of state machines in here too. Let's say because in a plant or process, there are states in your plants. Maybe the state changes are fast. It can be in a millisecond or half a second or something, but there are states. And traditional PLC program use ladder logic or FBD, function block diagram, and memory elements. Combinatory logic and memory elements to make control. So if you want to continue, this is the 70s and 80s, and they're still controlling using FBD and ladder logic. So if you are programming with combinatory logic, use ladder logic, because it's easier to look at the power flow when it's a coil energized. For FBD, function block diagram, you have to decode the logic, and if the logic is complicated, you have to decode what's going on here. And it's much, much easier. This course is structured text programming. It's much, much easier to read if you can program. And we are writing 2024, and there's a lot of high-level program, Python and so on. So if you can program high-level levels, you can read the program. You don't need a lot of documentation. You can make complex state machines. You can make state machine for sequences, even if there is a sequence program that you can use. So it's better to do this. So it is introduction. Look at this. Yeah, you can jump to this for programming, select some exercises, and then you can select one here, maybe the first one. So of course there's quite a few exercises here. We don't have to do all of those. And then this compendium, which is a reference, basically use it. It's guidelines, how to do timing, edge detection, some example, and so on. So you can look through the videos. About here is around 10 minutes each, but some are longer, especially the solutions here. They are longer. You just look through and see what they are. And the lectures too here at your convenience. That's information. And this safety and what you should do here, what such a system should do. There's not a lot of about factory automation in here, as I said, producing stuff in here, because that it depends upon the factory. But there's a lot of process control, because of process control you have control, regulation, and you have discrete control, start, stop things, which is also, of course, a part of factory automation. But then again, factory automation, maybe you could use PLCs for that, fast PLCs and so on. But still you could use structured text doing this program, making programs robust. And also remember, these automation systems, PLCs, they are meant to work for maybe 20 years. And if you have, let's say, a spaghetti program in there, a really shitty program in ladder logic or FBD or something that you maybe understand here and now, and you have tested and debugged it and so, but after 10 years, there's going to be a change on your plant. You get new equipment into it. And it's not object-oriented. It's just your spaghetti stuff. Okay, after a lot of time, this person is going to find out, okay, I have to do some changes here. He does these changes. And then he should probably have done a change somewhere else too, but it's not easy to find. And okay, you make the changes, load your program, everything works fine. And after a week, someone is going to call you, it's not working anymore. because then you have a glitch or a deadlock or something somewhere else in your combinatory logic and memory elements, God knows what. Or yeah, use ladder, because then you probably won't have these hang. Just because of something you have overlooked. And maybe they have restarted the system so the error isn't there anymore. But it would pop up maybe in 2 days, in half a year, or in another week. And then you say, yeah, I had to travel by plane, I'll go online. And usually you go online, I have to go online and look at it, but you have to stop your plant. You can't produce anything because I have to locate the error. That's going to cost your customer. And it's probably going to cost you in the end too, because he's not going to buy such a plant from you anymore. Okay, so that's it. So that's a little about the course. Introduction, what are we doing here? So here's, let's say, guidelines and stuff like that we're using, some lectures. And then there are introductory exercises, small and large, but not much. And then we have some simulations. We do some control. It's not controller tuning and so on. So that's what it is. So this was the content of the course. And again, repeat, we do only structured text programming. That's this legacy way of programming in what is started out with in the 60s and so on. We should probably retire those. We are writing 2024, and we have powerful programming systems available, high-level language programming. And also, I didn't mention the CFC, continuous function chart, that Siemens, they have got it, Codesys has got it, Beckhoff, they have got it, ABB have something similar, where you can use it as kind of like an UML tool too. Then you can say, okay, I don't have these class of function block and make, but I know they need this interface. Make the interface, do the program in CFC as a UML and say, okay, it's work, but no, this function block needs another output because I have to use it over here. And then afterwards you can fill in, you can code your function block using high-level language, or go for bit ladder logic. And then you have constructed your plan. Because automation, that's about factory automation too, is making objects play, coordinate objects, coordinate motors, valves, controllers, fasting, sorting. It's about coordinating objects that you have programmed as classes and have a PLC as function blocks. So that's what control is about.